Hey everybody, what I want to do today is tear down one of these old power supplies. And as you can see, it's a very nice power supply. It's extremely heavy and it just seems like it's built in that right time period. We'll get a better look once we take it apart. But multi-turn resistors for controlling your voltage, beautiful LED screen for your actual current and your voltage. So it's just a really nice thing, and it offers independent tracking and of course your earth ground. So let's just take a look at this. So I just want to start this video off by showing you the actual DC ripple here. And basically what I'm trying to illustrate that it's not that significant. It's just over a small resistive load of 33 kilo ohms. And as you can see right here, it's 20 millivolts per division, so it's very mild noise. And this is set at 22.3 volts for the actual power supply. Now there's one piece of engineering that really stands out to me, and it's actually the casing. The one thing I hate is you see all these perforations in here. If you're ever working around this and doing some prototyping, you know, maybe cutting a capacitor lead or something like that, and it goes in there, it can cause an electrical short and who knows what damage it can do. It's just one of those things that really stands out as a negative aspect to this power supply. Okay, now that we got this unit open, as you can see right here is our fuse. So this is protecting the circuit, and it's a 250 volts, I believe it's 2.5 amps fuse, and that's in line with the input from the mains, and then that's just being fed into this massive transformer. To be honest with you, I'm really impressed at the size of this. It's really a huge, massive unit. I don't know if YouTube will actually give it any justice. So then out of that massive transformer we go to these circuits here, and there's two of them. Obviously both the same because it's a dual channel power supply, and then both sides are capable of delivering up to 30 volts at 3 amps. And what we have here is, you know, your bridge rectifier, you know, your filter capacitors, your voltage regulators, and then right here some relays for when you switch to higher voltages, they engage to allow more flow. So it's a very nice little feature that you see in the high end. So in this unit, the heat is controlled by heat sinks here. As you can see, it looks like they have a sensor here which regulates it, so that way if you're overheating it turns it off. And so there's no fan or anything, which is nice because it's a quiet unit. So it's just massive heat sinks for controlling the temperature. Now inside we have these multi-turn pots right up here for controlling the voltage. The current's just a single turn pot. These ones are a 10-turn pot, which is a really nice feature. And then right in here is our actual current and voltage meter, which is really nice how they're in line. And they're both digital readout, and they work really nice. A really large crisp screen, which is a very nice feature. And right here is our tracking engagement. The only one thing I really don't like about this is some of the joints on this really stand out to be bad. Like this one right here. In between the negative and the positive, what we have is a cap. I guess that just filters out any of the noise between the the ripples. But it's really, to me, not an enduring feature of this unit. It's just because if you rattle it or do anything, it's not going to be a solidly held joint, so it's not a very portable unit. And of course you can see here is our earth ground, which is properly grounded to the chassis of the actual unit. So in that sense it does pretty good. And right here we have our indicators for constant voltage, constant current, and overload. So it's a very nice feature to actually see what you're doing if you have constant current or constant voltage. So it's one of those features I really like about this unit. So right here we come to an odd feature, and this is basically SMD on a through hole thing, which I thought was a little bit odd, and it really stood out to me because I haven't really incorporated this. For most of the things I've observed, it's usually generally all SMD, but here we see it's actually incorporating both technologies. So anyways guys, that's my basic teardown of this model right here. So thanks for watching and have yourselves a great day.